Guys, let's continue where we left off, which was that we had a basic app working. Let me actually zoom out a little bit more, which can show an image, and we can like pan around and zoom and things like that. So we can load an image and it shows it, and we can like zoom, pan, and we can reset things, and it's all good. So what would be nice to do now is to try to, so what I really originally wanted to do was to try to write a little GUI application that then also applied this Sobel operator, maybe possibly other operators, some ideas over here, to the image. So we want to do basically something that transforms the image from this to this. And it's this operation, which may look a little bit weird, but when we see it implemented, it's probably going to be a bit simpler. First of all, let's add a button that lets us run the operation. I'm going to add it at the bottom of the UI, probably here. That's just the main UI. So here we can say if the button run Sobel filter is clicked, then we are going to run an operation, and we'll implement it on the app struct. So let's say run Sobel. Okay, now we need to implement that. And in principle, I think we'd like more than one image. For now, let's try to say just like the processed image, everything's processed. And then we also need like separate scales and zooms and stuff for that image. So let's actually not do that for now. Maybe that's something we'll do in another video. We'll just replace all of this. Okay, so run Sobel, it takes a mutable reference to self and it does some stuff. If there is no image, so let's say self.image is none, then let's just return. All right, so to actually implement this, it would be very nice if we could get out the bytes themselves, and actually we have some code here. I just saw that lets us do that. So I want to convert it to grayscale, I think. So let's say pixels is the image. Actually, why don't we, if it's a bit more common to do something like this. So let's unwrap it and put it inside this kind of guard. So let's say the pixels are image, and we should be able to say like 2 luma, which is kind of like a grayscale. And then we can get the pixels. We can convert it to a vector, which I think I like. I'm not sure what this structure is. So let's see here. The image buffer as flat samples. We can also do that, I think, as flat samples. Returns a view on the raw sample buffer. It's kind of strange. Like, I don't really know how to use that. Okay, so let's say this is probably just like a vector or a flat array. So with that in mind, we probably also need the width. So image.width turns the width of the underlying image. That seems correct. And now we need to apply this operation. It has two parts. It has gx and gy. So what this notation means is that you go over every pixel and you replace the value of the pixel with something that is calculated from this kind of matrix. So imagine this central one is the pixel. You say +2 from the one to the left, -1 from the one to the right, and you add, and +0 of itself, and you add that up. Then you go up one row and you say +1, +0, -1, and so on. Hopefully it will make sense in a little bit. So the thing is, we want to write it into like a new buffer, and then put it into the image again. So we want to create a new image. So maybe I can say like, let's call it just Sobel, and it's a vector with capacity equal to, then we need the height as well. It's the height, and it's going to be width times height. And we can also put the type on it here just for measure. And this thing returns a grid. This should return what? U8s. So it's going to be U8s as well, I think. But we're also going to have negative values. So let's make it actually just integer. Let's make it integer. So as usize, and then it has to be like this. Okay. So this is the one where we're going to write the values themselves. And when we're done, so we're going to do a bunch of stuff here. And let's just see that we can actually get it to work. Let's say that we take the image and we kind of like, can we do like this? 2 luma 8 as flat samples mutable. And then I want to say like mute samples. And then I basically want to loop over. I say like samples copy, clone from, or extensor slice. I don't see that. Okay, so basically I want to say for index in 0 samples dot length, I wanted to say, but maybe I just do it on this guy. Let's say samples is equal to that. So it doesn't like that. So this one cannot be indexed by usize. Interesting. So it takes a tuple of indices, but it's called flat sample. So I wonder what the deal is there. Maybe there's like a set or get. That's not any better. This is very annoying. So we have to say like x is this, y is this, and maybe the color index is just 0. So then we say x, y, and let's go just ahead and convert those to 32. And still complaining here. Can it be indexed by usize? But I am not giving it a usize. I32, SU8. So could it be that the value is wrong? Like this has to be turned into a U8 or something? Or we don't use this? I don't really get it. Expected tuple. This. Okay, so it was correct before. Can we do anything with this? No, we cannot. This is so bizarre. So like, can I say copy or can I index it? Cannot index it. Okay, I think I found something. So we can enumerate the pixels mutably. It will give us two things. It will give us the x index, I think, the y index, and a mutable reference to it. So can we try to say this guy, it's a U8. So I kind of want to just be able to set it to let's set it to 125. So it's kind of gray. And that does not work. Can we check out what this is? It's just returning something which you don't know what is. It's annoying. So how do I actually work with this? So I can say 0, and that is something, and I can do this, I think. Really strange. Okay, I can do this. Strange notation, but I think it works. Let's test that it works. So I should be able to now click a button and set it to be completely gray. So it didn't do anything. And actually, the reason it didn't do anything is because we also need to, so let's say here, get temp buffer, run operation, copy to image, and then we have to remember to set up the image texture again. Right, and actually it's kind of bizarre that we can returns a copy. So that's a good point. We also have to put it back in. Maybe we just do it mutably, and then we have to say, I forget how we did it. We have to do this kind of stuff again. Image width, image height, image. So let's actually first set up the image. So self, or rather image. No. So it's annoying, it's creating a copy. It's creating a copy. So actually, this is not going to do anything. Okay, so let's say gray copy. Okay, that's image 2,8. So now we have the copy. Here we'd probably do this and then do some stuff. It's called 8. And on this one, we want to make sure we're actually changing the copy. And here we have to put the copy back into the image. So image. There's also as lumma 8, which is probably, it's a reference, and you can get it mutably. So that's interesting, but we kind of want the copy anyway, so I'm just gonna keep it that way. And maybe this is a, can I do this? Does that make sense? 2, right 2. And why is it actually an image buffer? That's kind of funny. But okay, dynamic image from gray copy. I don't know. Probably it's not going to work. Expected. Do I have to do this? Because it's a reference. All right. And we cannot borrow it as mutable because it was declared mutable. And okay, let's try again. Well, it's still not going to work because we don't really do all of the things here. We need to set up the texture as well. I think if we do color image, there's like this, because this is an option, I should be able to say like replace, turn the value without deinitializing either one. Okay, but that kind of do want to deinitialize it. Let's go ahead and do this. So, all right. Now we need to set up the texture, and how was it we did that? Actually, why don't we just reuse these functions? That's a lot smarter, I think. And here we can say replace instead. It's a little bit better, and same here. And we should ignore the old value. I think it's a better way to do it. Okay. So we delete this and we say self load color image and self load texture. And it needs the context, so we actually have to provide the context here, which I don't mind. Context. Let's see if we can compile it. You can also try to click this button now, nothing happens, which is good. And we run it as everything is gray. Okay, so that's perfect. Now we can actually modify the image. Now we can modify the image. So we do have the gray copy here. We actually need another gray. Well, maybe we don't. Maybe we don't need that. So let's do something like this. So IXP, and we can say in image as Luma 8. Okay, enumerate. That doesn't work. There's no enumerate here. Right, so we actually have to unwrap it. That's a bit annoying, but let's just do that. So we enumerate the pixels, and now we can do stuff. So what we'd like to do is say gray copy, like this, like this, and that. So that seems to work. But let's actually do something like this and then divide it by 2. And what we want to set in here is not really, doesn't really matter. And this one doesn't. So we do that. And so now when we, okay, that also didn't work because I forgot 0. So now when we run the function, it should just like make it darker because I'm dividing every pixel by 2. It should make it gray and darker. And it crashed. So why reference to an 8-bit grayscale image? So maybe it's because it's not really a grayscale image. We cannot do this. So against what I would like, well, I suppose it kind of makes sense. So, okay, so right now we're doing a copy, which is not so nice. Maybe we should put it to do. Just iterate over raw pixels and manually extract grayscale value. Because we're really doing a lot of copying now, which I don't like. Okay, so there you see, it works. All right. Is it possible? It's not possible to just enumerate. You have to convert it to something. Which, not so nice. Okay. So what do we want to do here? Actually, I need the kind of the reference copy anyway. So let's go reference copy and put that here. Reference copy. Because we would like to now apply those operations we looked at, these guys. And to do that, we need, like, let's say this row. You can say ref copy, and it's going to be ix minus 1, iy. And then we have to do this kind of weird thing. And that has to be multiplied by 2. Then we put this, we multiply by 0, and we put the same thing, and we multiply by -2. Right, so that's supposed to be the middle row here, -2, 0, 2, 0, -1. So the only thing we need to do is say, okay, that was actually +0, and this one was actually +1. Format it and see. Right. So that is a problem that we actually want this to be 32. Yeah, let's do it that way. Then we have to say this thing here actually has to be converted to an I32, and this one has to be converted to an I32, and this one has to be converted this way, and this operation will always return 0. I didn't know, I knew that, so anyway, we can just remove it. And now we have a signed integer, but here we need to do just a byte. Why don't we just convert it? And row unsigned apps. Okay, we can do that. Unsigned apps as you eat. Okay, let's try that. Let's try that. Okay, of course it's gonna crash now that I think about it, so let's not do that. Because at the very edges, these guys will like overflow. So it's very annoying to write all that. So let's actually write a little bit of a local macro, which is going to be called get. Okay, it's gonna get something. And what's it gonna get? It's gonna get from one index, and this is just like an expression, from the y index, this thing. And what is it going to return? It's going to be a block, maybe, I don't know. And it's going to say if ix is greater than 0, let's actually do all the checks here. So those have to be not greater than 0, but greater than or equal to 0. And this one is less than width. And this one is less than height. Then we have to return something. What do we have to return? We have to return, actually we need something here as well. Let's call it buffer, which is an identifier. And we'll say, please buffer, give me that one and that one, but cast it. Okay. Let's see if we got everything. And by the way, else, we'll just return 0. That makes a lot of sense. And now here we should be able to say something like this row, just to make sure, let's say it's i32, get from the ref copy i-1 iy, and this one times 2 plus, well, let's say, let's put the 2 in front, so 2 times that, minus 2 times get from the ref copy ix plus 1 iy. And what is it saying here? Non-primitives cast. Right, so that's an issue. We need to say get out the actual value. And that's unfortunate because so we have to also convert these. So we convert those. And then in here, we know it's within bounds, so we can actually convert it back. And this has to, it's really annoying with all these conversions, but I kind of don't see a way around them right now. So, right, and then this, well, let's not, okay, still is complaining, unnecessary. Kind of want, I need to ignore that, but I don't know how to do it right now. Okay, get rid of that. And did it actually improve our lives? Well, let's see. All right, so we already like, and we can still like scroll and stuff. That's pretty cool. So this should only give us the horizontal edges because we only considered the like x plus 1 and x minus 1. How do I want Clippy in plus 1? So can I go here and say like, is it like linter Clippy something something? I don't know. Let me look it up. All right, figured it out. So you have to say, you can Google it as well, but you say, you make a lint section and you say the specific error you got equals allow. Now it doesn't complain about that. So that's amazing. And now we actually have to also get the other rows. So let's say upper row, also on I32, but that was with a factor of 1 instead. So we have to say, okay, like so, and then minus get ix as I32 plus 1, I y as I32 minus 1. And then we can say like lower row is almost the same, except we have pluses here. And with that in mind, let's add it all together. Like this, a row, lower row. And do we have to like clamp it maybe? So let's clamp it between 0 and 255 and then convert it to a U8. Before we do that, let's take the absolute value and then clamp it. Okay, I cannot format it. Give me a second. Okay, I changed it to this way of writing it, so apparently that's one way you can do it. And I don't know why that. Maybe it's just me that made a mistake. And here it's missing comma. Fair enough. And fair enough. So I forgot some commas. That's all right. Okay, so now we have a little bit more of an accurate representation. All right. But actually, I just realized something with the zoom factor, that once you've zoomed in, you can never, doesn't really work the right way. So we have to work on that another time. But what I wanted to focus on was that maybe these edges that are more horizontal are not so well represented. And that's because we're missing a term. We are missing a good term. So we're gonna say this column. It's basically the same, except do this and then -2 ref copy +1. And then it's basically the same. Oops, this has to be get as the other case with the rows, except that we have to add things to, we have to shift X instead of Y. So let's say left column, right column. So we're going to shift this one to the left, please. And then we don't need 2. Don't need 2. One we're going to shift to the right. And this one we shift to the right. And now let's add those to this result as well. And let's see how that looks. Load an image, run the operation, and now this edge is much more clear, as you can see. So we also have some edge effects, which is kind of like the very edge of the image, which is kind of interesting. But yeah, it looks pretty cool. Is it even a little bit close to what they have here? Theirs seems somewhat smoother, I would say. Somewhat smoother. I wonder why that is. Maybe we can try to take the average here, like we have 6 terms. divide by 6. Okay, that's way too much. Well, I'm not sure, but I think we'll leave that for another video. For now, let's say that was it, and I will see you in the next one.